All right, let's go to page 25 and we're done. We're going to start by talking about points of inflection, which I have already kind of given you that word and we've talked about what they are. But here's where our actual definition is. So a point of inflection occurs when a function changes from concave up to concave down or from concave down to concave up. So it is your change in concavity. A point at, so it's like a location, not an interval. It is a point. It's not an interval of points. At a point of inflection, the rate of change changes from increasing to decreasing or from decreasing to increasing. And believe it or not, you kind of already know that if you know that it's where concavity changes. So we are going to write our fun chart. So based on the definition of a point of inflection, that it occurs when a function changes concave up or concave, basically when concavity changes. Well, in my fun chart, this is where the concavity changes, right? And so this is my point of inflection. Kind of like A-rock, if we're writing out an explanation, we really can't write out POI. We should be able to because really anybody in grading these exams or whatever knows what it means, but it is what it is. We're not going to really have to write that much, but we'd have to, and we can abbreviate some. We just shouldn't abbreviate it to POI, but we can do that for ourselves, right? Just so we know what's going on. All right, so you can see that if I change in either direction, it doesn't matter. This is where my point of inflection happens. Well, this is also where the rate of change changes from increasing to decreasing. So if you at least have the concavity idea in your brain, then you can think about where it is on the fun chart, and then you can tie it to the rate of change. Okay? We okay with that? All right, so let's see what this says. This says the graph of g of x is shown in the figure above. Use the graph of g to answer the following questions. Find any values of x where g has a point of inflection. Now, I'm going to put a little star here because technically we're guessing. And you're not going to be asked to guess on the actual exam. We're guessing right now just so we can learn what this is. And the reason I'm saying we're guessing is for us to actually find exactly where it is requires calculus, and clearly we're not in calculus, right? But we know that it's where concavity changes, so we can kind of estimate it. And that's really, you're not going to be asked to do that much. Again, we're just doing it now because we're learning. So so G starts here. It is concave up, and then it changes to concave down. It looks like it probably changes right about there. And I think that's a good guess because it's a whole number also. Points of inflection are not always going to be whole numbers. That's a disclaimer, but again, just to make our lives easier. Then we're concave down and then become concave up, so it looks like that's probably a point of inflection as well. Okay? At least in that neighborhood. You will be given, when you're actually asked for intervals of concavity and things like that, so to really say where exactly that's always concave up or down or whatever, you have to know where that point of inflection is. When you are asked that, there will be actual points, kind of like the purple ones I put there, so you know where it is, so you can use that number. You with me? They're not going to be guessing, so you don't have to worry about that. But on our best guess for right here, we would say that x equals -1 and 1. Because remember, it is the x values. Okay? Everybody okay with that? Awesome. All right, now, for each of the following intervals, we're going to determine the rate of change of g is increasing or decreasing. And then it says, explain your reason for each answer using the features of the graph. Meaning that I can't say that the rate of change is increasing or decreasing because I held my pencil up and it went flat or whatever. You know, I mean, we can wrap our minds around it that way, but we have to use actual stuff we know, which is really coming from the fun chart because we're talking about rates of change. Okay? So, from 3 to 4. So, here's 3 to 4. This part right there. Okay? And I want to know if the rate of change, now the function's increasing, but is the rate of change increasing or decreasing? What do you think? Increasing. Why? Concave up, right? And it's fine in your brain, and I know sometimes my words come out like that too and say because it's concave up. And that's fine because we're being all informal, right? When we get to be formal and we're writing this stuff down, if you ever write the word it, you better go back, reread it, mark out it, and write what it is, okay? Because it is never going to be okay. All right, so here we are here, and we're going from 3 to 4. So we can say rate of change of G is increasing because, oh wait, increasing, hang on, I left off a really important part here again. Increasing on 3 to 4, because is the rate of change always increasing? No, that's why we have to restate that. Because G is concave up, and once again, on 3 to 4, because it's not always concave up. So the last couple days, we've kind of left off the intervals because we were talking about quadratics, and they were always one or always the other, and so it was what it was. But make sure that you're actually stating it that way. We all good on that? What questions you got? Awesome. All right. So then let's look at -1 to 1. So from -1 to 1, we're right here. So do you think the rate of change is increasing or decreasing? Decreasing. Good. Now the function is increasing than decreasing. But again, we don't care about that, but the rate of change is decreasing. Good. So you write this out without just copying mine, and then I'll let you check it. Should be able to model what we had there. You can check yourself with me. I put the rate of change of G is decreasing on -1 to 1 because G is concave down on -1 to 1. We good with that? Beautiful. All right, then you do number 3 all by yourself, meaning you figure out what the answer is and you write it down. I think you can do just fine. And you can check yourself there. So rate of change of G is increasing on 1 to 2 because G is concave up on 1 to 2. We're all okay with that? All right, now, the very first time we had to write something like this, in the very first lesson, I wrote the explanations 2 different ways for you. I did one with a because, and then I basically did it backwards with a therefore, because I wanted you to understand you can say it however it pops out of your head. And if you understand all this stuff deep enough, you might switch back and forth, and it's totally fine as long as you're saying what you need to say. If you need more of a process, like I need to do consistency is important, which is for everybody really, then probably this way is a good way to go about it. Because if we kind of are consistent and say, I answered the question, right? It asked me what was happening with the rate of change. I answered the question, then I said because, and then I gave my reason. And then you can just be kind of consistent with that pattern, and that works just fine. Okay? We good with that? Any questions? The other thing is, on these kinds of questions, because I didn't see it a ton, but I saw it enough where I feel like I needed to say it. And I think it'll be less of an issue now because y'all all understand it better. But if you're going to write something out like this and you're going to tell me the rate of change is increasing, make sure it says concave up. Because sometimes I think maybe you have the right answer in your head, then you start writing it and maybe you're modeling something else next to it and you write the wrong thing down. So you want to make sure those things jive, right? Like it's decreasing and it's concave down. It's increasing and it's concave up. Then it actually makes sense with your fun chart. Okay? We okay with that? Questions? Awesome. All right, so now we need our calculators. I can't scroll. There we go. So I want you to turn your calculator on. You get to the black screen, 1 for new, then no, and then we're going to add a graph. We don't need a calculator, but we need a graph. Okay? So while you're doing that, let's go read this. So it says, for t being between 0 and 3, the number of cars in the parking lot, okay, so we're talking about the number of cars in a parking lot, at time t hours can be modeled by this function. Based on this model, at what time t does the number of cars in the parking lot change from increasing to decreasing? Okay. Is this question asking me about the function, or is it asking me about the rate of change? The function. Because the function represents the number of cars, and it asks me when does the number of cars change from increasing to decreasing. You with me? Okay. So we're going to go to our calculator and we're going to type this in. Now, this is in t's. You always have to use x's. Okay, so if you use a t in here, it's not going to know what the heck you're talking about. So let's type this in. This is negative 1.37x. And then to get to the fifth power, is it fifth? Yeah. The little caret top is right here next to 4. And then pay attention to what you're typing, because if I then just go, all right, that is plus 4 point, you see how it's typing up there in my exponent? So when you use the caret top key and you're up here, you have to arrow to the right to get the big cursor back. Plus 4.218x to the 4th minus 0.357 x squared plus 3. Okay. And then always double check that what you typed in is what you intended to type in. I think I'm good. So when I hit enter, this is what I have. Okay. Do we all have something that looks like that? All right, awesome. So let's go back and figure out what the heck we even need. I want to know at what time does the number of cars change from increasing to decreasing? So what am I looking for? If your function changes from increasing to decreasing, what happens at that point? What do you have? Is it a point of inflection? Look at this. So if I change, remember, here are my points of inflection, right? It's where my rate of change changes from increasing to decreasing. But when my function changes from increasing to decreasing, this is where the change is. What is that a point of inflection? What is that thing? A what? A maximum. It's a relative maximum, right? Even though we've been talking about points of inflection, that doesn't mean we're looking for a point of inflection. We got to read the question, make sure we can find this stuff correct. All right, so I'm looking for a maximum. I got that now. Now I'm going to go back and look what I have in my calculator. It is a polynomial because it says something to the 5th, which means my domain is all real numbers. Am I concerned with the entire domain of this function? No. Based on my question, what part of the domain am I concerned with? How would I know what part of the domain? 0 to 3, right here. That's all I'm concerned with, right? Like we used x, but t is our x. It is our independent variable, right? Does that make sense? So here's what we're going to do. I know I can't see what is most likely the maximum up there. I'm not going to waste the time playing around with my window to get to that. I'm going to change what I know I can change. So we're going to hit menu, and we're not analyzing the graph. 4 for window or zoom, and then 1 for the window settings. So I know the domain I'm interested in. My x minimum would be 0. My x maximum would be 3. And I know I need my y values to be higher. I don't know how much higher. I'm not going to spend time trying to figure it out. If I go too high, then it could be hard to read or something weird. So let's just change it some and make our y max 20, just to give us maybe something. And if that doesn't work, we're not going to worry about it anymore. And I hit enter. We have this. Okay. We all okay with that? So now I'm only looking at from 0 to 3. And even though I can't see it, do I have a pretty good idea where the maximum is? Yes. As long as I can get on either side of it, I'm good, right? So now we're going to calculate this maximum. Remember, we go to menu, and then what do we choose? Analyze graph, which is 6. Then we choose 3 for the maximum. And then that is to the left of it. I mean, clearly I'm intersecting that function, so that can't be the maximum, right? And I tap that. And when I move, oh, it didn't let me go all the way over here last period. I need to at least see where it intersects the blue, because I don't know that the maximum is actually right in the middle of this, right? So I just get to where clearly I'm on the either side of it. And then I tap that and boom. And then it changes my window back, but that's fine. This gives me a better look. I didn't know what to, didn't know how to mess with that. Good enough. Now, they gave me an ordered pair. Do I want the entire ordered pair? No. Do I want the x value or the y value? What do we think? X value. How do you know that? Because you had a 50-50 shot or what? How do we know it's x that we want? It's asking for t. It says, at what time t does the number of cars? This is t is the x value, so very good. So before you write the number down, let's answer the question. Now, when we're not being all formal like this happens because this happens, because we're using like our pie chart, you answer the question like you're used to answering questions. We can just rewrite the question a little bit. So based on the model, and we don't have to use every single word, at what time t does it, okay. So I can say the number of cars and I really think it's okay to leave off in the parking lot, right? Just the number of cars. I mean, that's the only thing we're talking about. The number of cars changes from inc to dec, you can abbreviate that, increasing to decreasing. Now, we've been using the word on a lot because we're giving intervals. I'm not answering with an interval. I'm answering with an exact point. So I say at instead of on, at, and use t, not x. T equals, how many decimal places should I write down? 4. We have to be correct to 3. We're writing 4. 2.4456. 2.4456. And don't forget your units. What are the units here? Hours. Hours. Okay. Everybody okay with that? What questions you got? Okay, beautiful. Flip this over. All right, so we have this function g here, and we're going to identify all these characteristics. Before we actually go down to the questions that are there, we are going to do a couple of extra things up here at the top. Because one of the things I did not list down there, because I knew I had room right here, is we are going to give the intervals where the function, let's see, is positive. G is positive. Okay, instead of just putting positive. Okay, not the rate of change, but G itself. G is positive, like where? Okay. So where does G start being positive? Where's the first time? Any idea? Okay, -5, is that where it starts being positive? That's the first time it ends being positive, right? So what's the x value where we start being positive? Very good. We go from -infinity to -5, right? I never include the infinities. Do I include this -5? No, because at -5, what's the value of the function? 0, and that's not positive, okay? Then so this is positive. And then is it positive again? Yes, starting where? 3 and going to infinity. Good. 3 to infinity. Everybody good with that? Okay. So then we have where g is negative. Where is the first time g starts being negative? Negative 5, okay. Now, negative 5, and then this is all negative down here, so can I just go from negative 5 to 3? What do you think? No? Some of y'all are shaking your head. No people, why no? Elizabeth, tell me why. Good, because at negative 2 it's 0. All right, so we have to go from negative 5 to negative 2. And then we start back over at negative 2 and go to 3. So basically we just have to skip over that point. All right? We good with that? Okay. If I asked when is g less than or equal to 0, then we could go from negative 5 to 3. Okay, but we're not actually including that when we just say negative. Everybody good with all that? Okay, perfect. All right, so now we're going to look. We've talked some about domain and range. It's definitely old business. We got to make sure we can write it correctly. What is the domain of this function? Negative infinity to infinity. Good. What's another way to say that? All real numbers. Good. Interval notation is negative infinity to infinity, but it also means all real numbers, but this is what I want you writing. Okay. The range. Where does what's the smallest y value I have here? Negative 9. And when it goes to what? Infinity. Negative 9 to infinity. I know I never include the infinities. Do I include the negative 9? Yes. And the way you answer that when you're talking about, like, we're not talking about intervals of increasing and decreasing and stuff, is you ask yourself, is negative 9 a y value that's actually on my graph? If the answer is yes, then we include it. Okay? Because sometimes some people still have no idea how to decide. All right, everybody good with those? Basic old business. Okay. Intervals where g of x increases. So where does g start to increase the first time? Negative 4, and we're increasing till we get to here, right? And then does it increase again? Yes. We're increasing here. So it's starting here and going to what? Infinity. Good. So we're going to be from negative 4 to negative 2, and then 1 to infinity. Any questions about that? Okay, great. What about where g of x decreases? Where does it start to decrease the first time? Negative infinity. It's decreasing all of that. So it's negative infinity to negative 4. And then we're decreasing here, right? Negative 2 to 1. All right, so negative infinity to negative 4. And then negative 2 to 1. Any questions about any of that so far? We all good? All right, great. Okay, relative maximum. First of all, what's another word for relative? Local. Good. So we're just going to go ahead and write that above it so that we remember. And, okay, so relative maximum, or maximums if I have more than one. How many do I have? Relative maximums. 1, and where is it? Negative 2. There's a relative maximum right there. So my relative maximum is at x equals negative 2. Relative minimum. How many do I have? 2. And they occur at x equals what? Negative 4 and at 1? Oh yeah, at 1. Sorry, as soon as I scroll on and remember what I looked at. Any questions about any of that? Okay, so then we have absolute. What's another word for absolute? Global. Very good. So we're just going to write this so that we can remember that we have more than one word. And I can have at most one of these. Global maximum. What's the highest y value that's going to happen here? Yeah, it's infinity, but that's not really a number, right? So do I have a global maximum then? No, I do not. My answer is no. Absolute minimum. First of all, what is the absolute minimum value? -9. And it occurs at 1. Okay. So absolute minimum is -9 at x equals 1. Because you could be asked for both things. So remember, the value, the absolute minimum value is the y value. Location is the x value. Okay? Everybody good with all that? All right. So then, points of inflection. Points of inflection occur when? When the function changes from what? When the function. Concavity. It's when the function changes concavity. It's when the rate of change changes from increasing to decreasing. Make sense? The absolute maximums and minimums, your turning points, is when it changes from, the function changes from increasing to decreasing. So the points of inflection, again, think about the cubic that you learned, and I think some of you were taught that that's the point of inflection. That's where it's where it's changing, but it doesn't change from, the function doesn't change from increasing to decreasing. All right, so here I put actual points where they'd be so we can find them. So here my function is concave up, and then it changes to concave down, and then we're concave down, and we change to concave up, and we get that. Don't check those points with any calculus because they're probably not right. I had to force this graph to work because I wanted to get whole numbers, and it was way harder than you might think it is. But I have 2 points of inflection, so they are at x equals what? -3 and -1. Everybody okay with that? So now that we know where those are, we can answer this next question, which is the intervals where G is concave up. Where does G start being concave up for the first time? -infinity. Good. And it is concave up from -infinity to what? -3. Good. Are we concave up again after that? Yes. Starting where? -1 and going to infinity. Good. Make sure you're looking at your graph because I didn't scroll. And then intervals where g of x is concave down would be what? -3 to -1. Okay. What questions do you have? Are we good? Okay. Are you starting to feel better about some of the other stuff that was freaking you out at the beginning? Yes, it's because we've talked about it multiple times. We didn't freak out. We're letting it marinate in our brains. We're doing our assignments, so we're practicing. And we're going to try and keep the stress level down so our brains will continue to work.